how to run conjoint analysis in R. I'm going to demonstrate going through the process of inputting the code and then also how to read the output and what the output shows us in your analysis. So I'm going to start by setting my working directory, and then I'm going to read in my data set. So a conjoint analysis is survey-based statistical technique which is used in market research. And this analysis will help us determine how people in a survey value different attributes within a product or service. So when given a survey where they have to rank a bunch of options, um, each option has different attributes of that product or service. So we can determine how important each attribute is in that option. So the data I'm using is mobile rankings. So we can see um, people were asked to rank different options of mobile plans, and each option had different attribute levels. So I'm going to call this data conjoint DF when I read it in. And then just looking at my data set, we can see the attributes are brand, startup cost, monthly fee, whether the service was 4G or not, whether it was sold in retail or not, whether an Apple product was available or not, or whether you could purchase a Samsung product or not, and whether you could purchase a Google Android product or not. And then we have the ranking that the consumer gave that option. So then we're going to set up our contrasts. And basically in our summary, attributes are translated to a set of variables. So attributes are one less than the number of levels of the factor. So if your attribute has 3 levels in R in the summary, it will only create 2 variables for each level of that attribute. So this contrast function allows you to compare every level to the overall mean. So now we're going to build our model, and our model is basically showing that ranking is determined based on the attributes brand, startup cost, monthly fee, service fee, retail, Apple, Samsung, and Google. So I'm going to call that model main effects formula. And then now we're going to fit that model into a linear model and pull in our conjoint DF data. So I have my main effects formula model and then our data conjoint DF. And then to get our output, we run summary with our linear model name. So this is what my output looks like. So looking at the summary, we are not going to look at our p-value because significance is not an important metric here. We're just looking at our coefficients estimate column. So we can see here our estimate number is also known as a part worth, which is also the value that the consumer places on that attribute and attribute level. So it's the strength that the individual puts on that level. So when you have a positive part worth, that means that there is adding value in the consumer's mind versus a negative part worth is taking away value to the consumer. So our brand 1, brand 2, and brand 3 are all levels in our attribute brand, and we don't have our 4th brand because that's excluded in this summary. So in order to get that, we can do a calculation using our part worth values here. So we have For brand 1, the 0.008, and then brand 2, 0.464, and then brand 3, we have a negative 0.456. So up here, I add them together, and then I'm taking this number down here and then subtracting that from 0 because all part worths within a level or within an attribute equal 0. So we can do simple algebra to calculate that. So we know that our fourth brand is negative 0.017. And just to associate which, like what brand 1, brand 2, brand 3 means, we can run this line of code to generate a list of what each level is. So now we can associate that our brand 1 is AT&T, and brand 2 is Sprint, brand 3 is T-Mobile, and then brand 4 is Verizon. So also an easier way for us to see, list out our different naming conventions for our levels within the attributes, along with the part worths associated. We're going to run this code up here, and this will generate a list of the part worths for each level within an attribute. So you can see here that there are four different levels within the brand attribute, and these are their part worths in order. And startup cost is the same. You have 4 different levels and their part worths. And then we can run these 2 lines of code to include our naming conventions up here. So you can see that for brand, we have AT&T, and then down here, the part worth for it is 0.008. And then our Sprint brand level within the brand has a part worth of 0.464, and then T-Mobile has a part worth of 0.456, and Verizon has that part worth that we calculated, but you can see it here is 0.017. So this is really useful to see within an attribute what level a consumer places most value on. So we can see that within brand, consumers have the greatest value on a Sprint because the 0.46 value is the highest value out of all these part worths. And then we can also see that T-Mobile takes away value to consumers because it has the greatest negative value, that negative 0.45. And then if we want to see, we can further see the importance of each attribute. So looking at our different attributes of brand, startup, monthly cost, service fee, and all these, we want to see which one has the most importance in the consumer's mind when choosing an option. So we can do that by running these lines of code, which will store that part worth value for each attribute here, and then sum them and use that to compute the importance value of each attribute. And these lines of code here will print out the output. So here you can see our different attributes, and they are all compared on a scale of 100%. So they're all given a percentage on how important they are in the consumer's mind. So our Apple seems to have the highest percentage of importance with the 35%. So consumers, when looking at options, seem to place the most importance on the attribute, whether the mobile provider has Apple products or not. And then Google Android products seems to have the least importance in the consumer's mind. So these are very useful because when a consumer is making a choice, we know that they have certain preferences and what they place the most importance in. And this allows us to see what attribute has the greatest importance, and then within that attribute, what level has also the greatest importance. And this can help managers make decisions on what options they should make available to the consumers because they want to create the greatest value for the consumer. And it can also help them maybe eliminate some options they have if the value is not as strong there. So then they should cut their costs on that option for the consumer. And that is how you conduct a conjoint analysis. Thank you.